Hi everybody, this is Dr. Hines. Glad to see y'all back for this semester. I'm really looking forward to seeing y'all. Some of y'all face to face, kind of be able to harass you a little bit in the chem lab. That's gonna be a lot of fun for me. But anyway, we're just gonna kind of get down to business here. So this is the second lab that we're doing, and you can see the title right there. We're gonna be doing essentially something called titration. It's a very valuable analysis technique for finding out concentrations or amounts of unknown materials. And here's the chemical reaction that we're going to carry out. And basically what we're going to do is you're grasping the concept of molarity and solution chemistry, reactions, aqueous, things occurring in water. And I don't know how far you got in your first semester chemistry, but we have an acid, which I don't know if you know the name of that acid. Maybe you recognize its formula. And we have it reacting with a base. Not sure if you know the name of that, but maybe that could practice on some nomenclature there. And when you take an acid and a base and you react them with each other, that's a very kind of specific type of reaction. Should I tell you what it is, or should I'm getting some nods that maybe I should review this. So when you take an acid and you react it with a base, we call that neutralization reaction. All right? And when you neutralize something, what do you always get? You always get some kind of a salt, got your metal, got your non-metal, and you always make water. So this is the chemistry thing of what's going on in today's lab. Now we want to kind of be able to quantify things. And what we want to be able to do is we want to be able to determine the concentration of acetic acid. So there you go, there's your nomenclature. The amount of acetic acid in vinegar. Now, when you buy vinegar at the store, it's on the label. It tells you how concentrated the acetic acid is in it. So we're going to do a lab and look at the chemical reaction between these to experimentally determine the quantity of acetic acid in the vinegar, and hopefully we'll get some reasonably decent results. Okay, so here's the math behind what's going to happen here. Now, we have this unique situation in which the reaction's balanced, and we have a 1-to-1 mole-to-mole stoichiometry between the acid and the base. So by now you've talked about a capital M, maybe the line's underneath it, maybe not. Capital M, that's the molarity of the acid, multiplied by the volume of the acid. What's the unit of molarity? Mole per liter. What's the unit of volume? Liter. What do you get if you multiply this times this? In effect, you're going to get the moles of acid present. All right? Because of the 1-to-1 stoichiometry, and even the equation says this as well, the molarity of the base times the volume of the base will give you the moles of the base. And because it's a 1-to-1 stoichiometry, guess what? These two sides are equal to each other. Now, when we do the experiment and we collect data, what kind of portions of this equation are you guys going to collect? Well, when we do this experiment, we're going to measure out a specific amount of acetic acid, and we'll get to that in a few minutes here. You're going to measure out a specific amount of acetic acid. We know it's labeled on the bottle. We'll show you a picture of that as well. We know the molarity of the base. We have a piece of glassware that's going to allow us to measure the volume of the base to carry out this reaction. So what one thing is not checkmarked up here? We've got all this data. We're going to use it to calculate the molarity of the vinegar solution that you've got. And hopefully with the results that we have, it'll be reasonably close to what the manufacturer says it should be. So in a couple minutes, we're going to kind of start looking at some of the procedure. I think this is probably good enough for you to kind of get a general understanding of what's going to happen in this lab, especially the mathematics of it. Okay? All right. See you in the next video.